In this video, we're going to put together everything we know about polynomial functions in order to gather every information we could possibly need to sketch the graph of these functions. So to start with, it's always a good idea to figure out the vertical intercept. In this case, the vertical intercept is 0. We're going to pass through the origin. When you evaluate f of 0, each of the three terms will be 0, so the function value is 0. The end behavior, right, as x increases without bound, what do the function values do? So that's going to be dictated by our leading term. So they're going to do the same thing that negative 2x to the fourth does. So as x increases without bound, it becomes 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000. Those are the numbers going into x. You raise that to the fourth exponent. So you're going to have 4 factors that are really large positive numbers. Then you're going to multiply that by negative 2. So those are going to become negative. So the end behavior of this function as x increases without bound, the function values decrease without bound. On the other end, as x decreases without bound, the function values will also decrease without bound, because now you're putting in something like negative 1,000, negative 1,000,000, negative 1,000,000,000. You've got 4 factors that are all negative numbers, but you've also got the negative 2. So all together, you're multiplying 5 negative numbers together. That result will be negative. So these values are going to be negative. So far, what do we know? Well, we know that as x increases without bound, the function values are going to decrease without bound. As x decreases without bound, the function values are again going to decrease without bound. And we know that the origin is our vertical intercept. So this is what we know so far. Next up, let's factor this function. So first off, we look if there's anything common we can factor out. And all these terms contain an x squared, and they're all even coefficients. So we could factor out negative 2x squared here. And let's think about what's left. So negative 2x to the fourth divided by negative 2x squared, that's going to be positive x squared. So double check that that's correct. Negative 12x to the third divided by negative 2x squared, that's going to be positive 6x. Right? Double check that gets you, when you multiply negative 2x squared times 6x, you're back to negative 12x to the third. And negative 18x squared divided by negative 2x squared, that's going to be positive 9 times 1. Right? Negative 2x squared times positive 9 is negative 18x squared. We can further factor that. In fact, look, that's a perfect square trinomial that you've learned about earlier in this module. That's x plus 3 times x plus 3, or you can write that as negative 2x squared times x plus 3 squared. So once we've got the factored form, right, we've got this factored form, what values of x make this 0? Well, what makes this first value 0? What would make negative 2x squared equal to 0? That would only be when x is 0. That's the only value that's going to make that true. And what makes x plus 3 equal to 0? Well, that's when x is negative 3. So again, 0, we already knew we had an intercept at 0, because that's the vertical intercept. And we've got a point here at negative 3. So we've been able to add some information to our graph. The last piece of the puzzle is what's going on in between. So from what we have here, we actually kind of know that the function is doing this on the ends, because that's what the end behavior of the function is. But what's going on in between here? What could possibly be going on in between negative 3 and 0? So to do that, we've got to choose a value in between those zeros somewhere. Doesn't matter what you pick. This time let's pick negative 2. See what happens. Is the function value positive or negative here? So what is f of negative 2? Again, I'm going to mostly be worried about whether this is a positive number or a negative number. So negative 2x squared, if we put negative 2 in, we have negative 2 squared, which is positive 4, times negative 2, that's going to be a negative number. Negative 2 plus 3 is positive 1, and when you do positive 1 squared, that is positive. So this is going to be the product of two numbers. One of them is positive, one of them is negative. So this is going to turn out to be a negative number. That means when x is negative 2, we're somewhere down here. we know we've got to get back to these zeros, so you're going to have something that kind of looks like this. So overall, the function behavior, we've got the end behavior we expect. The function's going to be negative in between our zeros, and it's going to end up as negative end behavior on the right. Let's use a graphing utility and see if this is right. See if this looks something like what we would expect. So yeah, when we plot this graph using a graphing utility, we see exactly what we expected. The correct end behavior, the correct zeros, and the correct behavior of the function in between those zeros. And let's do one more example from start to finish, everything we could possibly learn about this function. Again, good place to start is to find the vertical intercept. So when you put 0 into this function, you're going to get 0 cubed plus 5 times 0 squared minus 4 times 0. All of those terms will be 0. And then you got minus 20 off at the end. So you got minus 20 here as your vertical intercept. So again, what do we know about the function? It's going to cross the vertical intercept down here at negative 20. So just kind of add that to our list of things we know. The leading term, x to the third, that's going to help us determine our end behavior. As x increases without bound, the function values are going to increase without bound, because that's what happens with x to the third. You put large positive numbers in here, 1,000, 1,000,000, or whatever. When you have 3 factors of that and multiply them, you're going to get really large magnitude positive numbers. As x decreases without bound, the function values will decrease without bound. Right? Negative 1,000 to the third, that's a large magnitude negative number. So we can also add our end behavior on here. As x increases without bound, the values of y increase without bound, so we're going to have something like this on the end. As x decreases without bound, the function values decrease without bound. So we'll have something like this on this end. Next up, let's factor. So we take a look and we see, can we factor this in different ways? Well, there's nothing common. Like, for example, there's no coefficient that's common to all of these, or a factor of the coefficients that's common. Not all terms have an x in them, so we can't factor that way. But we could try factoring by grouping, which we just learned about. So let's see if we can factor this by grouping. So let's intentionally group the first 2 terms. And I'm going to make this plus minus 4x minus 20. And now let's factor out what's in common from each of the groups. So we get f of x is equal to, we can factor an x squared out of that. So we'll end up with x plus 5. And we can factor a negative 4 out of this. So negative 4x divided by negative 4 is positive x. Negative 20 divided by negative 4 is positive 5. So now both of these parts here have x plus 5 in common, so we can actually factor that out. We can factor that x plus 5 out. And we get x squared plus a negative 4, or we can just write that as x squared minus 4. Right? That's the idea of factoring by grouping. We're taking this common multiplier, this common thing being multiplied by both these numbers, we're pulling it out into the front here. Each of that is, if you distribute, you get back to what we had in the line before. We actually don't have to stop there. We can go one more step, because x squared minus 4, that's a difference of 2 squares. So we got x plus 2, we have x minus 2. So now we have it factored all the way we can, fully factored. In the fully factored form, we can determine the zeros, right? We want to know what values of x, I'm going to do this down here because I want to use the space below. So what values of x make this true? So what makes x plus 5 0? Well, that would be negative 5. What makes x plus 2 0? That would be negative 2. What makes x minus 2 0? That would be positive 2. So we're going to have zeros here at positive 2, negative 2, and negative 5. And so the last step is to determine what's going on in between these zeros. Right? We kind of know what's going on afterwards, right? We got to have this behavior and this behavior outside of those zeros, but what's happening in between? Well, actually, again, you need to pick a number that's in between your zeros to determine. We actually already have one. Between negative 2 and positive 2, we've already know that 0 produces negative 20, so we actually can just kind of fill in here the behavior in between those zeros. We know it's going to look something like this. In between negative 5 and negative 2, just pick something in there. I don't know, like negative 4. Just pick negative 4. So what is f of negative 4? And let's worry mostly whether this comes out to be positive or negative. So if you put negative 4 in to x plus 5, you've got negative 4 plus 5. That's a positive number. It's positive 1. Negative 4 plus 2, that's a negative number. It's negative 2. And when you put negative 4 into the final one, negative 4 minus 2, that's negative 6, so that's a negative number. When you multiply these three numbers together, you're going to end up with a positive number. So somewhere up in here, when you put in negative 4 for the function, you're going to get a positive y value. And so we're going to get behavior something like this. So if we graph this with a calculator or a computer program, we should see something similar to this function. Let's check. And so here we have it. Again, we've got the end behavior we expected. We have the 3 zeros we expected. We have the vertical intercept that we expected, and we have the function having the correct sign in between our different zeros. And so what we've done in this video is we've looked at ways to actually gather all the information you need to get a really good understanding of the behavior of the function throughout its domain by using all the things that we've learned over the last couple modules.